Thank you in advance for listening to our presentation. Our group includes 5 backend software engineers, and we build a full-stack public health application called EpiTrac. My name is Darby.
I'm Emily.
I'm Madeline.
I'm Sean.
And I'm Will.
Reportable disease data is generally in a spreadsheet and not very fun to look at or explore, so we built an application to make it more fun to explore diseases in the US. Our application enables users to access epidemiological data on a user-friendly and interactive map that displays weekly disease case counts for each state. Users can also find information about the diseases, find and save articles, and access more additional information from the site. I'll pass it on to Sean to go over the demo of our app.
Thank you, Darby. This is EpiTrac's homepage where you will see an interactive map. Clicking on the pen will bring you to the bottom of the page where you will see that state's weekly reported diseases ordered by number of cases. And if you click on a specific disease, it will bring you to a page for more information on that disease. One of our team core value is accessibility, so you do not need to be a login user to have access to all this information. Although if you do choose to log in, you can log in with auth using Google. And as a logged in user, you can have access to a dashboard, which then you could default your state or default your home state, which will be loaded at the bottom of the page. You will also have access to saving articles. So if you find an article that's really interesting, you can go ahead and click on it and you can save it to your dashboard. And once you're done showing all your loved one about that disease, you could go ahead and delete the article. And I have another one saved here. And last but not least, there's an about page about our developers that worked on this app and a little bit more information about our app that we built and where we got these information from.
Our application uses a service-oriented architecture with separate backend and front-end services. Both services followed REST conventions and MVC architectural design pattern. We used a relational database, PostgreSQL, to store information about users, diseases, and saved articles. Both services were built with Ruby on Rails, but the front end also includes JavaScript, HTML, and CSS. Bootstrap was also utilized on the front end to aid in styling. For user authentication, we used Open Authentication with Google OAuth 2. We used the testing framework RSpec and several gems to unit and integration test the application. Our front-end and back-end services were deployed using Heroku.
Looking back at our tech stack, it becomes evident that our front end would have benefited from technologies such as React. React's addition of tools such as reusable components would have aided our front-end development greatly, considering how our application heavily relies on visuals and interactive page elements. In addition, React uses a virtual DOM as opposed to a traditional DOM, which improves page loading times and provides a smoother user experience.
In the future, we'd like to implement the use of caching and background workers to make EpiTrac more efficient. Currently, when the user finds articles for a disease, saves an article, and goes to their dashboard, each of these features makes virtually the same API call. Instead of fetching the same data 3 times, we could store the data received from the first API call and then fetch the data from memory when needed. We'd likely want to reset the cache daily so that the data updates regularly. Another future plan for EpiTrac is to move the third-party API consumption out of the HTTP request response cycle by incorporating asynchronous background workers. This would speed up our application and also ensure that external downtimes don't affect our user experience.
Over the course of the 10-day timeframe working on EpiTrac, the project had to undergo many changes. One of the most important documents for facilitating communication and planning for these changes was the Miro board. The Miro board allowed us to brainstorm and decide which features we wanted to implement for a minimum viable product. This is also where wireframes and the JSON contract for API endpoints were created. An example of the many changes our team had to make during development was having to make updates to our JSON contract, and these changes were all documented on the Miro board. Because of such changes, it was vital that clear communication was maintained. We had daily stand-ups to discuss our progress, our goals, and blockers. We also had a GitHub projects board to keep track of which user stories were being worked on. As a result, everyone on the team was on the same page, and this ensured that nobody was unproductively struggling. All of this, along with a friendly team atmosphere, ultimately made for a successful project.